Hello. Hello. Hello, Niranjan. Hello, Niranjan. Can you hear me?
Hello, Gokul sir. Hello, sir. You are audible, right?
Yeah, yeah, yeah. Thank you. Hi, Surya. Hi, everyone. Yeah, can
Sir,
we begin the workshop?
sir, can we please wait for 5 minutes?
Yeah, yeah, sure, sure, sure.
Thank you, sir. Good morning. Hello. Good morning to all. Respected Principal C.H. Srinivasarao sir, Vice Principal sir Mr. Kishore Babu sir, Mechanical HOD Sushma madam, and trainers Mr. A. Gokul Krishnan, Senior Mentor Pair AI Robotics India Private Limited, and Mr. B.K. Niranjan from Pinwheel Robotics. And my dear friends, I welcome you all to the robotic online session arranged by the Techfest IIT of Bombay, IIT Bombay. I hope all of you are eagerly waiting for the session to start. So I don't want to take much of your time. I request the trainers Gokul Krishnan sir and Niranjan sir to start the session to enlighten us. Thank you all. Hello, Niranjan. Hello, Niranjan sir.
Hello. Hello. Surya.
Hello, sir.
Yeah, now it's working. Thank you.
Okay, sir. We can start sessions.
Yes, yes, yes. So first of all, good morning to everyone. Yeah. So let me share the screen.
Mute all this.
Yeah, I hope you can see my screen. Just confirm.
Yes,
Hello.
sir.
Yeah, you can see my screen, right?
Yes, sir.
Yeah, thank you. Yeah, so first we'll start with the session. So before that, I want to know so what are all the students like present here? Like, what are the department student present here? Which department they are? Hello.
Hello, sir.
Yeah, yeah. Which department the students are presented here?
Sir, there are from all departments.
Okay. So mixed up. Which year actually? First year. Okay. First year.
All 4 years are combined, sir.
Oh, combined mixed. Okay. Okay. Thank you. Thanks for the information. Yeah.
Thank you.
So I'll just begin with the session. So Techfest IIT Mumbai. Okay, this workshop is based on Techfest. So which is going to happen in 17th to 19th December 2024. So it is conducted by IIT Bombay. So that's a small introduction about this session. And then so we are the workshop partners, Pinwheel Robotics and Para A and Robotic India Private Limited. Yeah, first let me just explain the about Techfest. Techfest is an annual science and technological festival organized by IIT Bombay. So it's like Asia's largest college festival, attracting participants from across the globe. So which includes workshops, competitions, lectures, exhibitions, and so much more. So in that, so main key lights if I'm seeing is like competitions, like hackathons, coding challenges, like that, and workshops like whatever we are learning, no? Like that. So you'll be having AI and machine learning, blockchain kind of things. So in the lectures and exhibitions, you will be having some speakers from some academic industry and then science. So it will be like that. So this is what they are mainly focusing. So let's move on to the company introduction. So first, Pinwheel Robotics. So Pinwheel Robotics is a Bangalore-based company. So which is like an ed tech. So here now, like they are doing the design and development of DIY robotic kit and aiming to the STEM education and focusing on mainly the children, like training all the things. So one more workshop partner, Par India Robotics. So this is a leading edtech company in the education, the STEAM education, and here AI, IoT, AR, VR, robotics, 3D printing. So these are all the things we are doing, and so we'll be use it to teach, train the students from K-12 education. So our main focus is on DIY kit. Yeah, it's a small introduction about the workshop partners, and okay, let's get into the competition. So, have you all just gone through this tech fest? Anyone? Hello. Okay. So let me explain about the competition. So we are focusing on the Cozmoleclnch and Meshmerize. So first, okay. So let me show the tech fest thing. So this is the website techfest.org. So please just go through after this session. So here we'll be having the details about this competition and workshops. Everything will be available here. So you can register and you can participate with your team. Yeah. So as I said, so we have two competition. One is Cozmoleclnch, next one is Meshmerize. Let me explain about the Cozmoleclnch. So Cozmoleclnch is a robotic competition held during IIT Bombay Tech Fest. So in this event, what they will do means like, so the participant has to build the gripper robot to perform specific task in the time limit. So there will be a arena or kind of a play area. So there you have to build a bot using a gripper mechanism. So it has to perform certain tasks which is given to you, and it has to move the objects, and it has to cross a lot of obstacles in that, and then it has to complete the thing. So this is what I'll show you the arena, then you will be getting an idea, and I'll show you some video, so you'll be getting clarity on that. Fine, yeah. So Cosmoclunch, you have any doubt about the introduction? Okay, fine. So I'll just move on to the next slide. So as I said, so this is the Cosmoclunch arena. So here you can see, uh, yeah. So there is one written right here, one. So there your start begins, and here you have to start your robot, and it has to go, and it has to pick some blocks in between, and it has to put it in the some area. There is a deposit zone, and there you have to put it. I'll just explain you the rules and regulations of that. Wait 1 minute. So it will be available in the website as well, you can just get it. So yeah, so these are all the rules of this competition, Techfest, Cosmoclinch. So the task they already I mentioned, na, so it's a manually controlled robot which has to have a gripper mechanism. It has to pick and place some blocks, and it has to put it in the proper place. Like they'll be giving a target zone. There you have to place it. So this is what the task, and there are certain rules and regulations you have to follow when you are doing this project. And so coming to the dimension, your board dimension should be 300 cross 200 cross 300 so this should be there in your thing. And then the bot must be controlled manually. So here no autonomous, the bot should be controlled manually. You have to control the bot. Yeah. So next thing, it's your choice. You can control wire as well as wireless. That's up to you. And there is a certain meters they have mentioned for the wire length. So it's 2 meters. Just keep it in your mind. And if you are using wireless mechanism, you can either use a dual frequency remote or Bluetooth or Wi-Fi. Anything is fine. Yeah. And dimension of the board are not included in the size constraint of the board. Yeah. So remote size is not an issue, not a problem. You can just go through. The bot must have an onboard power supply in any case. Yeah. So the bot we have an onboard power supply. So just we have to control manually. That's it. And yeah, so this is the important thing. You should not use Lego parts, Lego things, no? Lego kit you should not use. Yeah, the mechanism used should be such that only one person will control the bot. Yeah. So only one person has to control this bot. And yeah, power supply, coming to power supply, so you can use up to 24-volt DC during the run. mm, and there is like you should use onboard electric or non-electric power supply. There is power source should be on the bot itself. Okay, you have to keep the power source in the bot itself, not like a wire connected to the socket or something. Okay, coming to the arena, so this is the arena setup, size and everything they have given, deposit zone, everything they have given. You just go through it, so you'll be getting an idea. I'll show you some video, then you'll be getting the clarity. So coming to the view position of the arena, so this is the top view, so you can just see. So your bot will start from here, and it will go, and there will be some blocks. You have to pick it, and you have to put it in the deposit zone. So that certain task it has to complete, and it has to climb this ramp, and it has to come here, and it has to finish it in the fourth. It has to cross over this, and it has to finish it in the finish position. So here multiple perspective of the arena they have showed. Can you just have a look? And so here is the task, basic task they have given, and there will be some time limit for this. Yeah, so this will be available in the Techfest website. So just go to the competition, and yeah, techfest.org, Techfest competition. So Cozmoleclnch, Meshmerize, both the things are there. You can just give explore and problem statement. If you're clicking, it will take you to this rule book. You can just go through it. So now let me show the video of this Cozmoleclnch. So already some of them have done it. So can you able to see the video? Please confirm.
Yes, sir.
Yeah, sure. I'll just play it. Can you able to hear the audio? Check once. No, right?
Yes, sir. The audio is clear.
Audio is not coming.
Not coming.
Okay, okay, fine, fine. No problem. So this is like a trial run. Let me show the Cozmoleclnch which IIT Bombay have done. Yeah, so hope you all have seen the video. So like this only, the bot has to be built. So they in that video you have seen one is wireless and one is wired. The first video having the wireless thing, and second video will be with wired. You can use anything; it's your choice. So next, I'll just explain the next competition that is called a Meshmerize. So Mesmerize is like it's kind of a line following robot that you have to do, and it has to navigate through the maze, and the robot has to memorize the maze, and in its first run and then its subsequent attempts it has to find the shortest path to complete the course. Okay, so I think you all know about line following robot, right? Hello.
Yes, sir.
Yeah, so just a minute, my video is not visible. Okay. Okay, fine. I think some of them are familiar with this thing, this kind of robots. So it's like a line following robot you have to do, and it has to cross some maze kind of thing. So there is an arena for the separate arena for this. So I'll just show it. First, in first attempt, it has to take a, uh, it has to memorize it, and the next run it has to follow the shortest path. Let me show. So can you see this? Can you see the arena? Meshmerize arena. Okay, so the line following robot you have to start from here and it has to follow the line, and yeah, so in the first run what it will do means it will just move all around, and it will go to the finish thing here. Here it will start and it will go like this and it will finish here. So the next attempt, it has to find the shortest path. Like in the maze, it is like that only now. So it's trying to escape, like shortest path it has to find, and it has to finish it in the end position. So that's how this robot has to behave. So now let me show the dry run video of this Meshmerize project. Yeah. Okay, hope you all have watched the video. Yeah. So can you just explain, like, can you just summarize what you have seen? Hello. Yeah. Anyone?
Hello.
Yes, Ten. Yes, yes.
Sir, can we use already used bots like a remote control car? We'll give remaining commands to that and test the
Which one you are selling?
correction of
Cosmoclnch or Meshmerize?
Cosmoclnch, sir.
You are telling like remote
Already,
already.
yeah, sir. Already used bots like a remote control car. We just generally see playing kids, right?
No, no, no,
Can
no.
we
Actually, you should.
can we
Yeah,
can
that
we
is the next point. That is the next point. So you have to use the DC motor, and you should not use any controller in that. So which will be available in the this one, the rule book. Okay, you have to build the thing, and the remote also. Like I'll tell you, like what are the remotes. So manually controlled remote or wireless thing also you can use. So you should not use a pre-built thing.
okay? We have to build for that.
Yes, yes, yes. That is the next slide.
Okay,
Actually, I'll show you that.
okay. Totally manual.
Manual, manual.
Okay, sir.
So Cozmoleclnch is completely manually controlled bot, and this line following robot is autonomous. There should not be any human intervention in that. It's autonomous.
Okay, then in this, the car has to be built manually in this also.
Yes,
That I remember.
yes, 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 yes. You're telling only chases or how it is?
What's that?
You're telling only for the car chases or a complete setup.
No, second one, sir. That one.
Line following means. That
Yeah,
also same.
yeah, yeah, sir.
Chases and all you can get from outside and you can assemble it. But the internally you have to program it, right? So that you can program using some microcontrollers.
Okay, sir. Thank you.
Yeah, thank you. So yeah, so now let's see some technical information of the bot that we are going to build. Okay, so classification of robot. So robots are classified into manually controlled, autonomous, and hybrid. Manually controlled, you already know, right? So it's controlled by human. Autonomous. So once we have programmed, it has to work. And hybrid is both the things, like human, manually controlled as well as autonomous. So I'm coming to manually controlled robot. So which is related to the Cozmoleclnch project. So just you can just concentrate on this. So first one is wired control. As I said, wired control, we can use the DPDT switch, kind of a like joystick. You can use this. So DPDT switch. Any idea about DPDT? What is DPDT? Yeah, DPDT stands for. Yeah, I'm getting the answer. Yeah, it makes this session more interactive. Yeah,
Double pull, double through.
double pole, double throw. Yeah, very good. It's double pole, double throw switch. So yeah, exactly correct answer. So one is wired control using double pole double throw switch, and next one is wireless control. You can use RF, Bluetooth, Wi-Fi, or any other thing you can use. It's up to you. So these things you can use for the Cozmoleclnch project. Let me tell about DPDT. Yeah, first we'll just see the differential drive. So these are all some modules they have given. One is RF and one is Bluetooth, Wi-Fi model. Yeah. So next, get into introduction to differential drive. Do you know about differential drive? Okay. So differential drive is a mechanism, like it's a system like in which two motors are independently controlled, allowing the robot to steer by varying the speed and direction of the motor. So usually the motor will rotate in how many direction? Hello. Okay, fine. So usually the motor will rotate in two directions. One is forward, backward. That's it. So forward in the sense clockwise, backward anti-clockwise. Yeah. So the differential drive mechanism, what they will do means like to varying by varying the speed and direction, they'll be controlling the motor. So it's called like for example, if you want to turn left, so but your motor will rotate in two direction only. It will not rotate left and right. So what you have to do is you have to control one motor, and you have to control the speed of one motor, and you have to increase the speed of one motor. Like that you can do. You can just minimize the one motor speed and you can maximize the other motor speed. Like that you have to control the direction. For example, if I'm saying left turn, so my left wheel has to change its direction and right wheel has to change its direction so that it will turn the left. Okay. So let's consider left only. If left is there means my left motor has to go in the backward direction. My right motor has to go in the forward direction. So there will be a left turn. So same way, like if I'm turning the right, my right has to move to the clockwise, anti-clockwise direction. My left has to move to the clockwise direction. So it will make a right turn. So this is what the differential drive, and here they have used that caster wheel. Can you able to see the white color thing here in the front of the chassis? So hello, yeah, yeah, please. You have any doubt? Okay, I'm just getting the things. Yeah, double pull, double throw. Okay, here I got something. First, it has to travel through all the paths and found that it ends. Actually, run it followed by the route without dead ends and reach the fine. Okay, thank you. Yeah. So someone was asking some doubt. Please, please, please. I'm open to answer. Okay, no doubt. Fine. So this is the differential drive mechanism. So this you have to know because of you'll be varying the direction in the Cozmoleclnch as well as the uh, line following robot. So this differential drive mechanism you should know. So this is the one method of controlling the uh, s- speed of the motor and direction, so that it will turn to the whatever direction we are giving, like whatever the inputs we are giving, based on that it will turn. So this is one logic. As I said, left motor has to rotate backward and right motor has to rotate forward, so that it will turn the left direction. So any other method is there for turning left and right? If you know, please tell.
Maybe trying to rotate the front wheels.
I'm sorry.
Uh, the front wheels are tilted, so the car should be directed where it should go.
Okay, you are telling the front wheel in the sense like front two wheels and back also two wheels, like that. Total four wheels you are telling.
Yes.
Okay. So no, in that mechanism we can use that axle thing, that steering kind of thing. So here that also, like with differential drive, you have to control only two motors, right? Here I'm telling. So this type of methods will be having two motors, and so this is the wheel called caster wheel. So which will move in all directions. So whatever this wheel is behaving, this wheel will support the two things. It can move in all direction. So like in trolleys we'll be having the wheels, trolleys and the rolling chair. So the same wheel which can move in all direction. Only the control of the direction will be happened in the motor. So I'll tell you one more method. One is changing the direction of the rotation of the motor, and one is we can reduce the speed of the motor. So for example, if I'm reducing the speed of this motor and I'm increasing the speed of the motor, then it will turn the left direction. Same way, if I'm decreasing the speed in the right motor and I'm increasing the speed in the left motor, in the sense the car will move in the right direction. So this is one method. Like this we have lot of methods. So two methods, as I said, one is controlling the direction and one is controlling the speed. If you have any other method, you can please tell if you know. So basically these applications are done in robotics, autonomous vehicle and simple mobile robots. So they will be following this differential drive mechanism to turn the car in the left and right direction. So coming to the working principle, the robot moves by controlling the speed and direction of the each motor independently, and forward both the motor rotates in same direction, so at the same speed. So it will be forward, and left in the sense the right motor moves faster than the left motor slows down. Yeah. So this is one method. The right motor has to move for faster than the left motor, so it will move in the left direction and turning right. So left motor has to move faster than the right motor, so it will move in the right. So reverse, both the motors has to rotate in the reverse, I mean the backward. Yeah, advantages: simple design provides efficient control over steering and movement. Yeah, so this is a simple design, so no need of any steering here. So you can just varying the speed and direction, you can control the motor. Okay, so basically the I said DC motor will motor, right? Motor, so motor will rotate in two direction. So how will you control this thing? Like for example, it has to rotate forward as well as backward. How will you control? So how it will behave if you're giving a power, if you're connecting a DC motor to a battery, how it will behave? Either it will rotate in forward direction or backward direction.
Forward.
Forward. Okay, so motor can be rotated forward as well as backward, so based on the polarity how you are giving. For example, motor will be having positive negative terminal, and a battery, right, basically it will be having positive negative terminal. So if you are connecting positive to positive and negative to negative of the motor will rotate in the forward direction. Okay, if you are reversing the polarity, if you're changing the polarity to positive to negative, negative to positive, if you're changing means the motor will rotate in the backward direction. So this is what. So there is a switch called DPDT switch, as I said, double pole double throw, so which will be changing this polarity. So whenever we are switching on, so the polarity will be connected, and if you're switching, then the polarity will be changed. uh, yeah, so first let me show the Niranjan sir.
Yeah, Gokul.
Yes sir. Sir, do we you have the DPDT switch control thing now?
Yes.
Yeah, can you show the video once?
Yeah, 1 second.
Yeah, so Niranjan sir will be showing the DPDT switch, so he already have a circuit connection that he will be showing now.
Guys, can you see this DPDT switch?
Yes, sir.
Yeah. Yeah, Gokul, just explain this.
Yes. Yeah, so before, okay, this is like gripper, no? This is gripper. Okay, after explaining gripper, I'll just show this. Okay, so that is a DPDT switch, so which he is showing, and you have to switch on and switch off in that. Not like switch on and switch off, it's like changing the polarity. uh, yeah, so it's like two-way. Yeah, thank you Niranjan, thank you. So once I'm explaining the gripper, you can show the gripper working mechanism using the DPDT switch.
Okay.
Thanks for sharing. Yeah, so double pole double throw, it's a type of switch. It can reverse the polarity of the current, allowing to change in the direction of the DC motor direction. Yeah, used to control DC motor by manually toggling between forward and reverse direction. Yeah, so basically this is the circuit diagram of this DPDT switch. So here you will be having A, B, C, D terminal and E, F. So this C and D is connected to the battery, and A and B is connected to the motor generally. So now when you are switching on, this A and B will be connected directly, in the sense this positive and this is also a positive. Okay, this C and A will be connected to the motor, and D and B will be connected to the motor. So now positive negative is connected to the correct polarity. I mean the A is also positive, B is also positive, C is also positive, D is negative. Sorry, A is positive, C is positive, B is negative, D is negative. So it will be connected properly. So it will rotate in the forward direction. Whenever you're toggling it, now A and F is connected crossly and B and E is connected crossly. Now what will happen if you're toggling? D and F will be connected. So what will happen? This negative will go to A and C and E will be connected. This positive will connected to the B. So now the polarity will get changed. So the motor will rotate in the backward direction. So this is how it is working. So any doubt on this?
Oh, sir.
You understand the concept, right?
Yes, sir.
Yeah. So just changing the polarity of the thing, right? That's it. So this switch will help you to change it instantly. So if you're doing manually, right, you have to connect on one motor, like you have to put a separate wire for that, for another one battery you have to do. So here nothing, like just toggling it, you'll be changing the direction of the motor. That's it. So wiring for DPDT of differential drive, two motors connected to DPDT switch, switching the poles allow you to control different direction of each motor. Diagram. Is it a basic DT switch? Okay, fine. Yeah. So coming to the robotic gripper. So can you explain like why this gripper is needed?
To hold the blocks in place and dropping
Yes,
areas.
yes, exactly. So in the Cozmoleclnch, the task itself, you have to pick and place the blocks in the some position, some predefined position you have to put it. So for gripping that, for picking that, you need some component. It's called as gripper. So gripper is nothing but it's like a DC motor only motor, and which will work in the gear mechanism inside it. And so whenever you are giving a power, this motor will get rotated and inside the gear will activate, and it will pick it, I mean it will close it, like that it will pick. And when you are changing the polarity, it will be releasing it. So this is how it works. This is a gripper you have to use. So you can just connect it in the your board, over the board, so that it will pick it and place it. And the controlling and all you have to do the same DPD switch you can follow, and you can do the picking and placing. So precise control, a DC motor drives the gear assembly, translating rotational motion into force to record for the gripping. And you can control the speed so that you can adjust the grip of the thing. And so mechanical amplification, the gear system amplifies the motor stack, enabling adjustable gripping strength and control. Yes. Versatility, this setup allows the reliable handling of object with varying size. Yeah, variable size you can control, and weights, offering the flexibility in the robotic application. Yeah, this is what the robotic gripper. Now Niranjan sir will show the gripper thing, how it is working, all the things. We already have the pre-built gripper setup. So Niranjan sir, can you please show the gripper working? Yeah. Yes sir, you are on mute actually.
Hello,
Yes
can
sir.
you
Yeah.
hear me?
Yes sir.
Yeah, this is a gripper, how it looks like. Using DPDT switch, we can control this gripper.
Yeah, now he is switching on, so the gripper gets open, and yeah, so now it will be closed. So the polarity will be changed now, and I'll again. So basically a DC motor which is connected to a gear mechanism, so it will control the uh, that gripping thing. Yeah, it's connected to the battery and connected to a switch. That's it. Yeah, thank you Niranjan.
Thank you.
Yeah, fine. So as I already said, so this is done by varying the speed of the thing. And how will you control the motor normally, like using a microcontroller or something? So there is a component called as motor driver. So it's called as L298N motor driver. So have you heard of this before? Hello.
No, sir.
Okay, fine. So it's a motor driver. The name itself, it is going to drive the motor. So basically, if you're connecting to an microcontroller such as Arduino or something, so you need something to drive the motor, not only the microcontroller. So there we will be using this motor driver. So it's called as L298N motor driver. Basically, we will be using this, and one more version is there, L293. That's also there, but we are not. We are just using this L298N. That's a one specification motor driver we are using, and then this L298 motor driver is a arch bridge motor, a motor driver which allows the to control the motor to DC motors and controlling the varying speed and direction. Both the things you can control using this motor driver. There we are controlling manually. Here you can control it using the code. That's what. So let me brief about this motor driver. Yeah. So you all know about DC motor, right? Direct current motor. So yeah. So DC motor can be connected to this motor driver. Mm, 1 minute, I'll
Gokul sir,
show
one
you one.
second.
Yes.
Yeah, your screen is not visible. Can you share the screen?
Oh, is it? Okay, okay. 1 minute. I'm sorry. Can you see?
No, sir.
Niranjan, can you see my screen? 1 minute.
No, no, no. Yeah,
I
now it
hope
is working fine.
it is visible now. Yeah, sorry guys.
Yeah.
Okay. So yeah, now I'm showing the L29810 motor driver. So this is how it looks like. As I explained, it's like a motor driver which is going to control the motor in differential drive, as well as like whatever mechanism you are using, it will be controlled. But here no, here you can't control manually. Here it's like fully like using the code. You can just code it, it will control the motor. So but here you have to use a microcontroller. So I think you will be familiar with Arduino. So here there is a setup using an Arduino L29810 motor driver with a DC motor connected to a Arduino. So this Arduino will be giving supply like to the motor driver to control this DC motor. So let me show this motor driver thing. So how many of you used motor driver before? Yeah, I think Naranjan Shah is showing the video. Yeah, thank you, sir. So what he is showing is the motor driver thing. So how many of you have used this? You can raise your hands. Okay, no one used.
ఎందుకురా నాని నీకు నా మీదంటే అంత ప్రేమ?
Sir, would you like to unmute?
Gokul sir. Guys, 1 second. Guys, please be patient. Gokul sir is again joining because of some network issue.
Hello. Can you hear me,
Yeah,
Niranjan?
Gokul. Yeah, Gokul sir.
Sorry guys, like there was a network issue. My internet got disconnected. Okay, so can you hear me now?
Yes, sir. You can carry on.
Yeah, thank you. So where I left off, sorry, I forgot. Like L298 motor driver we were seeing. 1 minute, let me show the thing. So what are the things we have seen? Like where I was left off. Hello.
Motor driver connected to RT.
This I have explained, right? The time I was here earlier, I guess. Hello.
Yeah, Gokul
Niranjan sir.
sir. Yeah, explain about the driver.
Yeah. So this I have completed, right? This I have.
No, Gokul sir. Not at
Okay,
complete.
might be I think I left off here only. Okay.
Yeah.
Yeah. Okay. Fine. No problem. I'll just do this once again. Okay. So coming to the motor driver, this is the pinout, and here you'll be having the output 1 and output 2, output 3, output 4. Here you can connect the motors, the DC motors you can connect. Two motors you can connect here, 2 or 4 in your choice you can connect. And so these are all the power ports, power pins. So here you will be getting the 5 voltage as an output, and 12 voltage you have to give it as an input, and ground is there. So ground in the sense negative, already know. Okay, as I said, so the DC motor will be having two property. One is speed and as well as direction. So the speed is controlled using enable A and enable B, and the direction can be controlled using input 1, input 2, input 3, input 4. Yeah, so this is what. So input 1 and input 2 will control output 1 and output 2. Input 3 and input 4 will control output 3 and output 4. Yeah, so that's it. So once we are doing connection, that time you will get to know what is the use of these pins. So this motor will operate from 12 voltage. You can give 12 voltage. It is sufficient to run the motor based on the motor requirement. So the name itself I showed, right, like L298N motor driver. So because it's like the IC which they have used in this is L298N motor. Sorry, L298N is the IC name. So that's why it's called as L298N specification. And so there is a voltage regulator IC and 5 volt enable jumper. Okay. So this will control the motor when you are connecting to one microcontroller. So that's it. So any doubt on this motor driver? Yeah, fine. So comparing to DPDT switch, a DPDT switch is manually controlled. This should be done by the coding. That is the only difference. This IC will take care of the things. This will control everything. Yeah. So there is a circuit diagram they have given how to connect to Arduino. So how many of you are familiar with Arduino? Okay. Yeah, you can raise your hands so that I'll get a clarity. Yeah. Thanks. I'm getting some response. Guys, please respond. Others? Okay. Thanks. So here there is a simple connection they have done using the motor driver. So using this you can control the motor through the Arduino, but you have to do the coding here. Okay, there is a comparison. You just see, like I said, no. So DPDT versus L29810. So features first control. So as you said, like DPDT switch, it will be controlled manually, and the basic control for forward and reverse. Only this mechanism you can do. Forward and reverse mechanism you can do in this. And here automatic and PWM for speed. PWM I'll explain you. PWM for speed and direction control. And yeah, so this is automatic. You no need to switch on manually, it will control it automatically. And direction control achieved by toggling switches manually. So the direction control can be done by switching the things. And here L298 motor driver achieved programmatically via microcontroller. Next, speed control. So speed control, no direct speed control here, and but here now you can use PWM method to the control the speed. So complexity, simple wiring but manual operation. And so here slightly complex allows automated control. Yeah, here it's simple wiring. You can connect 6 wires, and this will be controlled easily. And here it's like complex, slightly allows automated control. Application basic DIY projects, and here it's like advanced robotic applications. So this is what the comparison. So practical example, application example they have given. One is like assemble the chassis to the 2 DC motor, connect the motors to the L298 motor driver, use a microcontroller to control movement, direction and speed, implement differential drive logic to the make the robot to move direction. Okay, here we can apply this differential drive to the motor driver by controlling the speed and the speed or direction of the motor. You can do it. Yeah. So before going to the Arduino, we all will have some bio break for 10 minutes. So now time is 10:45. So 11, sorry, not 11, 10:55 we can join. You can just, I'll just keep the thing as it is. You can just go for a bio break and you can come back. Okay, 11 o'clock only we can start, not a problem. 15 minutes we can take a bio break. Is it fine, Surya?
Oh, yeah, okay.
Yeah. Okay, guys. So keep the screen, let it be. You can just take a break. We'll meet again 11 o'clock. Thank you. Hello.
Hello, yes, sir.
Yeah, guys, are you back? Yeah.
So we can start.
Yeah, sure. I think I can't access this video. I can't share my camera. Do you have to change anything in the settings?
Once try again.
Uh, do you have to rejoin or how it is? Okay, fine, let it be. It's not a problem. Okay.
Sir, you are the host, you can present the screen.
Yeah, sure. So, yeah, my screen is visible. Yeah, thank you. Niranjan sir, I can't share my video. 1 minute. No, my video. Okay, fine. So, introduction to Arduino and Arduino ID. Let's start with the Arduino. Yeah. So, Arduino is a microcontroller. What has been my microcontroller? Hello. Yeah, just tell your things on like microcontroller. What is why we need that microcontroller? Okay, fine. So let me explain. So the name itself, it is there, microcontroller. Micro means
Small.
small. Yeah, micro means small, and a controller, it's going to control something. So there is a small thing which is going to control everything. It's called microcontroller. The microcontroller basically, we are starting with Arduino, and this Arduino, there is an IC, okay, which is going to control the whole setup. Okay. Yeah, Niranjan sir, can you show the Arduino once on the screen? Hello,
Mute
Niranjan
yourself.
sir.
Yeah, sir. Yeah, Gokul, sir. Tell me.
Yeah, yeah, you can just show the Arduino. Yeah.
You know.
From my side,
Okay.
the video is stuck actually. Niranjan sir, your voice is breaking.
Okay.
Not sure, like from my side only the problem, or Surya, can you confirm? Yeah, now it is visible. Yeah.
Visible, sir.
Yes. So this is what the Arduino microcontroller, so which Niranjan sir is showing. So this complete setup will be connected to some sensors as well as some output devices like motors. So all the actions can be done using this microcontroller. Yeah, thank you, sir.
Yeah, thank you, sir.
Yeah, let's begin with Arduino. Just a second, I will share my screen. I hope you can see my screen.
Yes, sir.
Yes, sir.
Yeah, thank you. So let's begin with Arduino. So some of you already know Arduino. So anyway, I'll just give some overview of Arduino. Yeah. So this is the microcontroller basically, so which will control the sensors as well as the output devices. So for this, we have to do some coding using the Arduino IDE platform. Yeah. So fine. This Arduino, will be having an IC called as Atmega 328P. So this IC is going to control the all the sensor and as well as output device operations. So whatever we are doing now, so that will be added in this IC. It will be uploaded and which will control the things. That's it. So first of all, what is IC? Any about idea about IC? IC stands for
Integrated circuit.
integrated circuits. So lot of circuits integrated together to form this IC. So that is what the name. So Atmega 328P is the IC we have used in the Arduino and which Niranjan sure showed is an Arduino, that is also same Arduino but the IC will be different, and in the sense the IC model is different. This is one type of IC, same IC only, but this is SMD. They used to say it as SMD, surface mount device, but this they used to say is a PIC IC. Yeah, so you can see this is also same Arduino and this is also same Arduino, this one, but the IC, the same IC but with a different structure they have used. This is SMD and this one is PIC IC. That's it. That is the difference. Okay, so now coming to the Arduino thing. So this Arduino will be having some input pins, general purpose input output pins. So you have heard about sensors, right? Sensors.
Yes, sir.
Yes, sir.
I think mostly you will be crossing across sensors in the day-to-day life. Okay, in malls, in everywhere, like in metro, everywhere you will be having the sensor things. So these sensors and all will be controlled using this Arduino, and there will be some pins for this for connecting the sensors and as well as the output device. Output device is nothing but the motor whichever doing actions. So we used to say it as actuators, action doing items. We used to say it as actuators. So let me explain about Arduino. It's an open source electronic platform for building the projects, and it uses a microcontroller to control the devices. Key features. Okay, so here you can ask a question like which programming we are using. So it's like C++ basic, and then multiple IO pins are there for the sensors and motors. Arduino IDE, as I said, Arduino IDE is a platform, software platform that I'll show you, so that we can open and you can code in this, and this code can be uploaded to the Arduino. Yeah, so workflow in the sense, so you'll be having coding and the coding has to compile and it has to upload to the Arduino, then it will work. According to the code it will work. That's it. Okay, why Arduino? So we have lot of microcontrollers like Arduino and microprocessor like Raspberry Pi and STM we have. So why we are choosing Arduino in the sense like beginner, for the beginner it's like friendly and with affordable cost, and for rapid prototyping. Cost wise also it's fine, like it's not much and it's user friendly, you can use it, and rapid prototyping you can do. Next, so as I said, GPIO pins, let me show the Arduino once again. I'll explain from the image, then I'll just move on to the pins. Okay, so here you can see some pins. I'm zooming, right? So it starts from 0, 1, 2, 3, 4, 5, 6, 7, and it ends with 13, and then ground A reference is there. Okay, so till 13 it's like digital pins. They used to call us digital pins, and here you will be having analog pins, A0, A1, A2, A3, A4, A5. So total 14 digital pins and 6 analog pins in Arduino Uno. And here we have some things. This is called power pins. This is the power pin which is giving power to the sensors as well as actuator you can take. So this will give the power to the whole setup. You can, but this Arduino need a power, right? And this Arduino will not work just connecting a battery. You have to give some power to this thing, and so which is by like two things. One is this one. This is a USB connector. So here you can just code the Arduino as well as you can give the power, and so that's the one thing. And here you will be having a adapter, sorry, pin. So DC jack there will be there. So here you can connect a adapter, or as well as battery also you can connect, so that it will give the power. So now let's move on to the input voltage for this Arduino. So the Arduino will be start working on the 5 voltage. If you're giving 5 voltage, it will be start working, and till 12 voltage you can give. I am advising to give till 20 volt. If you can give up to 20 voltage, uh, above 20 voltage you should avoid, because the operating voltage is 5 voltage and the maximum voltage 20 voltage. If you are giving above 20 voltage, the board might get damaged. Okay, so have a limit, use 5 voltage. If you are giving 4 voltage, it won't turn on. If you are giving 12 voltage, it will work for nice. Till 20 you can give, maximum 20 you can use. Above 20 you just avoid, otherwise the board will get damaged. So that's it. So as I said, analog pins A0 to A5, so total 6 digital pins, 0 to 13, total 14 including 0. So that's it. The specification they have given here: operating voltage 15 voltage, it's not like 15, it's 5 voltage work, and digital pins 14. Okay, which in which 6 are PWM things. PWM I'll explain here, I said. So 6 input pins, that's it. So this is what the Arduino. So the digital pins and analog pins I said, right? Okay, what is digital, what is analog? Any idea?
Digital is like computers, zeros, ones, all that. And analog,
Okay,
toggling on, toggling off, or any other
yeah,
signal from. It's like
okay. Thank you. Yeah, correct, perfect. So digital is like true or false, like high and low. You can tell, as he said, 1 and 0. Okay, so either if it is 1 means it's high, low means 0. So like that it will come. Yeah, you can control this using the digital pins, and analog pins is something different, so which will be giving some values to you. For example, like our exam marks, so it will be varying. So the analog pins will be giving some certain kind of voltage. Okay, so based on that the outputs will come. That's it. So generally it is called as GPIO. So both the input as well as the output things you can use in this. Input in the sense sensors, output in the sense actuators. Actuator is nothing but DC motor, LED speaker, and servo motor. Whatever the motor, you can connect it to the output ports, output pins. And GPIO, sorry, input, you can connect the sensors, because sensors are giving inputs, so you can use that. Yeah, so what I said, it's explained in this slide. So total digital pins for 0 to 13, total 14 pins. So here you can connect either input or else output you can connect. And if you're seeing that the 0 and 1 pin, it's like transmitter and receiver. TX means transmitter, RX means receiver. Yeah, here they have given, right, TX, RX. So 0 is receiver and 1 is transmitter. So digital states. So digital state, high means 5 voltage, low means 0 voltage. But analog, it will vary, that value become vary. Basic functionality, inputs reads digital signal on and off. Output that drives components like LEDs or relays. Show the pin node. Okay. Okay. So this is a simple coding to glow a LED. So using a digital pin they have done. So here they have initialized to the thing. In initialization, LED pin 13 they are connecting, and then void setup, pin mode they are setting is an output or input. LED is obviously an output, and loop they are doing, it's a LED blink actually. So LED will be high for 1 second, delay is like 1000 in the sense you have to convert it into for seconds. This is microsecond, you have to convert, sorry, millisecond it have to convert into seconds. So 1 second will 1000 means 1 second will come. So digital, right? Okay, first it will be high now, it means like it will be on for 1 second then off, so it will look like a blinking. Controlling components like LEDs, buzzers and relays, reading inputs from buttons or switches. So this is how the basic programming looks like in Arduino. So here they have used digital pin 13. If you are using analog, you have to tell it as A0, A1 like that. Okay, now let's move on to the analog pins. So in the analog pins, as I said, the voltage will be varying between 0 or to 5 voltage. Each analog pin has a 10-bit resolution, giving values to 0 from 0 to 1023. So whatever the sensors you are connecting, some of the sensors having, not some of the sensors, most of the sensors will be having some values. So which will be common, it's like 0 to 1023. So this is the common value we will be having in some sensors. And functionality reads varying voltage levels from the analog sensors like temperature sensors or potentiometers. So you will be getting some values, but in digital pins you will be getting only 1 or 0, something like that. Yeah, that's it. These values are converted to a digital number using ADC converter. Okay, there is a function in that Arduino IDE. There you can convert this analog signal value into digital. So there is a method called ADC. You can use that, so that if you are having an analog value from a sensor, you can convert into digital. Same way, digital also you can convert it to analog. Yeah, so here they have given one example using the analog pins. So here they have done one variable resistor port pin A0 they have connected, and there is a variable 0 starts with value. So starts with 0, the variable name is value, and so yeah, so the value will be analog value which is read by port on the potentiometer in the A0, so which will be printed over here in the output. Yeah, so far you have any doubt you can ask. If I'm fast means you just tell me, I can reduce my speed.
Fine, sir.
Fine, right? Okay. Okay, guys. So now moving to the pulse width modulation, I have been telling for a long time. So PWM, pulse width modulation, is a methodology. Okay, you have to use to control the average power delivered to the some electronic component. So this is what. So to explain this, some they we used to say it's like a pseudo analog signal, because why means like so here you can see. So digital, as I said, it's zeros and ones. Analog is varying from 0 to 5 voltage, and yeah, so digital means zeros and ones, na. So PWM they have mentioned here, and PWM there is a kind of a wave symbol. So you can see here near to the 3, 5, 6, 9, 10, 11. Total 6 pins will be having this PWM thing. PWM pins 3, 5, 6. Sorry, 3, 5, 6, 9, 10, 11. So what is PWM in the sense? So as I showed the DC motor driver, in that there is a 2 pins called. So what are the pins in motor driver? Can anyone say?
3 inputs, 3 outputs.
Okay, output we have, and inputs, 4 inputs was there actually. Addition to that, we have enable pins, right? Enable,
Yes, to enable
yeah,
this.
enable A and enable B. So both the things, if you want to control the speed, you have to use that enable pin, and you have to connect it to the PWM pins of the Arduino. So the Arduino, what will so the PWM, what it will do means, I will show you one thing on. Okay, so do you know modulation? Modulation. What is modulation? Generally, you can tell.
Maybe changing the frequency based on
Yeah,
the
exactly. Okay, changing the thing. Okay, modulation in the sense changing. So you know FM, right? Frequency modulation, right? So there, what they will do is they will change the frequency, and certain frequency you'll be receiving some signal, and you'll be getting the audio from that. Okay, here also same method, pulse width modulation. So generally, how the analog signal looks like? Any idea? Analog signal, analog.
there'll be pulses ranging from low input
Yes,
to
yes.
high value.
Yeah, so sine wave, right? Sine wave, sinusoidal wave.
Yes,
Yeah, sinusoidal wave. But digital will be like a straight line on down. It will come. If it is 0, it will be down, and if it is 1 means it will be up. So that is what the digital. Digital will not be having that varying thing. But if you are seeing this pulse width modulation, the okay, this is the thing you can see here. So the 0 voltage it will be down, and 5 voltage it will be up. That is what. But in the PWM pins, what it will do means it will behave like a analog signal. Sorry, analog signal. For example, if it is starting from 5 voltage, 25% only if it is using. So 5 voltage in the sense it will be going to the down, and it will be coming. Okay, this is the PWM method. The width of the pulse we are varying. That's it. Pulse width modulation. It's a pulse. This width we are going to change. See here, 25% duty cycle. You will be getting a full thing. Okay, it's low. 25% it will be 5 voltage it is coming, and after that 0, after that 5 voltage, after that 0, like that. 50%, 50% 50% power it will be going 5 voltage here down. Yeah, 75%, 100%, 100% is 5 voltage. So the value is 0 to 255 is the value. 0 to 255 is the PWM value we are using. Okay, if you want you can note it down. So this is very important actually. Okay, so 0 to 255 is the PWM value. If you are giving to a DC motor, you have to give like this. If the motor has to run at a particular speed, you have to use this value. If you are giving 100, the speed will be medium, and 120, 160. Based on that, it will work. Till 255 you can give. 0 to 255 is the PWM value. So now it's behave like an analog signal, like up and down, up and down. Basically the DC signal, yeah, the digital signal will not be like a like this. Okay, either it is 0 or in the max, but here it looks like a analog signal. So so this is a pseudo analog pins which is giving a digital value in the format of analog. That's it. So the width of the pulse we are changing. It's called as pulse width modulation. Got it?
Yes, sir.
Hey, guys, if you have any doubt, please stop me there and you can ask me. Okay.
Yeah, okay.
Yeah. Okay. So that's it. Okay. This PWM method we are using to control the speed of the DC motor. Next. So IR based proximity sensor and it's working. Okay. So why I'm taking this sensor here? So this is fine. This is for motor movement, everything. Okay. You can understand this. So this Arduino also for controlling the motor driver, everything. So why I'm using this IR sensor? Any idea?
Line following bot.
Exactly. Yeah. So this line following robot will be worked on the some sensor value. Okay. So why I'm particularly picking the IR sensor? Any idea? What IR sensor will do?
It detects the objects.
Yeah, exactly. It will detect some
Emit
objects.
IR rays and like receive that. It will see the fluctuations and it will detect if at all any obstacle is between that.
Okay, got it. Yeah, exactly. So the IR sensor will be having a transmitter and receiver. So as he said, which will transmitter will transmit the IR rays, and so if there is an object nearby, it will sense and it will come back to the receiver. Okay, what is the principle? Yeah,
Time required means like the projection
basically.
and transmission and
Hmm,
receiving. The time gap between
hmm,
the transmission and receiving
um,
of the light.
understand. Okay, so transmitting. So okay, we can call it as a reflection, right? Reflection of light.
Yes.
Yeah.
Yeah, so there's basic principle of behind this IR sensor is reflection of light. So the transmitter will transmit and to a shortest path it will detect, and it will be going, the light will be going and it will be hitting the object and it will come back to the receiver. So then it will be getting some values. So this is how it is working. Have you seen IR sensor in real time life?
Remotes, TV remotes.
Exactly, TV remotes. Okay, nowadays the remotes and all Bluetooth and Wi-Fi controlled remote. So previous days like it will be like IR remotes only. IR sensor will be there in the remote and some receiver or transmitter receiver will be there in the TV. So it will communicate according to that. And one more thing. So this IR sensor what we are using is like it will detect only the shortest object, shortest distance. So if you are keeping a object in a little far, okay, it won't detect because the range is very less. So it depends on the IR sensor, it will vary. So here we are using IR sensor for detecting the line. Okay, how it is detecting the black line and white line? How it is differentiating? Okay,
So
it
the
has to
white
detect
light
only the object.
reflects more light.
Yes. Yeah.
The white area reflects more light and black
uh,
area absorbs more light.
exactly, correct. Okay, so generally that black thing will be absorbing the light, right? So black objects will be absorbing and white object will be reflecting. Okay, depends on that only it will work. So when the signal is falling on the white thing, so it will get reflect, and so that it will identify it as an object, so it will move. So when it is touching a black, so it will be it will not be coming back, that light ray will be not be coming back, so it will be stopped. So based on this only this is working. IR means infrared radiation, and there is a potentiometer here. Okay, the potentiometer is nothing but to change the sensitivity of the IR sensor, you can just use it. Potentiometer, it's called as variable resistors. There is 4 pin in this IR sensor. One is VCC, ground, next one is A0, D0. Okay, what is VCC?
Positive power supply.
Yeah, so positive, you can connect, for example, how much voltage required to the sensor, you can connect it from the Arduino, and you can give a power. And ground,
VSS, the negative term.
ground is the ground,
VSS, negative term.
negative, exactly, negative. And A0 in the sense analog output, D0 digital output. So any doubt on this IR sensor? But you can we able to see the IR ray?
No.
You can't see using our naked eye. So there is a method, there is a thing we can use it. What is that?
Like a mobile camera.
Yeah, exactly. So you can use a mobile camera, and you can just use the sensor, or that old remote also. If you're pressing now, so if you're placing the camera on top of the sensor, you'll be seeing a pinkish light. So that is the IR ray that you can't see using your normal eye. Using a camera you can see. So in the line follower, mostly we are using this IR sensor, so to detect the line. So that is what we are explaining. So summary, we have seen digital pins, analog pins, PWM output. So this is a sensor now, so you can connect it. VCC ground you can connect, and if you want A0, you can connect it to analog pin. D0 means digital pin you can connect, but you have to code it accordingly. Okay, now we came to the Meshmerize line follower. How it will work, everything. What is a line follower? Yes. Okay. So line follower robot, already you know, so not much to explain. Predefined. So the robot has to follow the predefined path, typically a black line or a white line, white surface, or vice versa. Anything it can be. Application: autonomous navigation, predefined path, industrial automation, competitive robotics, maze solving competitions like Meshmerize. Okay. So basic components which we record for right. If you want, guys, if you want, you can note it down. So if you that a line follower robot has to be having these things of components like microcontroller, uh, example Arduino. Mostly we are using Arduino, so which will control everything. Sensors, now only we have seen IR sensor, and motor, DC motor, or servo motor. If you want, you can use it, servo motors also. And motor driver, L298 motor driver, power supply, battery. So these are the basic components requirements for the line following robot. If you're building, you can use this, so it will be useful for you. And we have given some circuit diagram here. So motor driver is a separate connection we have given here, and battery is connected, IR sensor is there. So now depends on the sensor value, this motor has to work. That is what the logic. Power is different. This IR sensor will be giving some value, depends on that this motor will be working. And it is like in our suggestion we used to have 5 IR sensors, so that you will be getting some accuracy in that. Not only two IR sensor, you can use 5 IR sensors, so that the accuracy will be high. Okay, and before going to that, So we have on line follower robot. Niranjan sir, we have, right? Kindly confirm.
Yes, sir, we are having.
Yeah, I can just show that video. So we have built the IR sensor, sorry, line follower using IR sensor. So now Niranjan sir will show that. Yeah. So now you can see. So this is the chassis, and so can you explain like what are the things we have used in that? You can just point out and show, sir.
We are using this IR sensor, 4-pin IR sensor. This is also type of IR sensor, 3-pin IR sensor. Okay. This is the Arduino board, and this is the power connection. This is the motor driver to drive the motors, and these are the motors wheels. We placed IR sensor, 5 IR sensor to get accurate this line following. This is the chassis. Yeah, these are the components which we are used in line follower robot.
Yeah. And you can include a switch also. So
Yeah.
switch is not in the PPT. You can just add a switch so that you can control it easily. So as he showed, so like that you can build it. So sensor, the components are all basic components only, not much. Arduino sensor, motor driver, motor DC motors, power supply, and then one switch. Sensor inputs, sensor detects the line and sensor signal to microcontroller logic based on the, yeah. So basically it will be working on the principle called IPO, input process output. So input in the sense like sensor will give the input, then it will go to the microcontroller. I'm referring to Arduino, and it will go from Arduino to DC motor. It will go input process output is DC motor. So like this it will follow. And so one thing, this line following robot, if you are building like using this components only, it's fine, it will work, but there will be a shake in that. If you are keeping on a surface, which means like a black path or white path, anything it can be, there will be some shake. So there is some algorithm to get the accurate sensor value so that the robot will move in a smoother way. Basic algorithm for the sensor, this is a basic algorithm. If IR sensor detects the line on the left, turn left. IR sensor detects the line on the right, turn right. If sensor detects the line in the center, move forward. If no line is detected, stop and search for the line. So this is basic algorithm you have to follow when you are building an line follower robot. So next, maze solving through line detection. A maze solving. So this is what the challenging part. So maze solving robot finds the optimal path through a line-based maze, which where intersections and junctions are critical decision points. So as I showed the Meshmerize arena, there will be some T junctions. Okay. Okay, let me show one more time. Okay, looks like my internet is less. Yeah. So you can see here. So generally that line following thing, it will start from here and it will go like this. And where the challenges will come means like the robot has to turn, right, either this way or this way, the T junction. Here also this way or this way, here also this way or this way, and here also this way or this way. So here only the challenge comes. So there will be some certain techniques you have to follow um, to get that particular thing. So there is an algorithm, you can follow that. And so real world application, intersections and decision making based on the sensor readings. No physical wall, just path, metal, insurance, flat surface. Okay. So usually in the maze there will be like walls, right? So but here now it's open, right? So it has to get some decision by its own. So one is left hand or right hand rule. Always turn left or right at intersections until the robot finds the exit. So this is the basic thing we are using, left hand or right hand rule. So what it will do means the robot has to turn left or right whenever it is finding a T junction. That is what they have mentioned here. So if it is going here, either it has to turn left or right. So left in the sense it has to go left and it has to take a U-turn here, and it has to follow the thing and it has to go here. So right in the sense it has to go here. So these all the things we have to do manually, in the sense like manually we have to calibrate and we have to make it. First it has to take a decision whether it is right, because it's a sensor value, right? We have to so that we are using the 5 sensors, so it will take an accurate thing. So first we have to understand the logic, like how the sensor has to get the value, how it has to behave for that. Generally these things we are using left and right hand rule. Always turn left or right at an intersection until the robot finds an exit. So next one is flood fill algorithm. The robot maps the maze using the line intersection and marks the dead ends. So first this is flood fill algorithm. This also if you want you can use it. So here what the robot will do is, but first it will map the maze complete. It will do, and you'll get the value. That value you can make it, and then next time you can use that value and then you can do it. Backtracking algorithm. The robot keeps tracks of its path and backtracks when it encounters a dead ends. So here the robot will be moving reverse. Okay, whenever it is finding a dead end, it will move reverse and it will find a path and then it has to go. So these are the three algorithms we are having, and mostly we'll be suggesting this left hand or right hand rule. The handling junction. The robot must decide which way it has to turn on the intersection, left or right, based on the sensor readings. Yeah, this is what I'm telling. So if you are doing this left hand or right hand algorithm, so first it has to check the sensor readings, then it has to make a decision. Recognizing dead ends. The robot found it's a dead end. No line is dead end. It needs to be reverse and backtrack to the lost decision point. So once it reaches last decision point, it will be turning to the correct direction. Yeah, solving a line maze with a line follower algorithm outline detects intersection. Use multiple sensors to identify the junctions in the maze. T junction, cross junctions. Okay, you can use multiple sensors instead of using only 2 sensors. That's why I told in that circuit diagram itself. They have used only 2 sensors. If you're using 5 sensors like Niranjan have shown, na? So like that, if you're doing, the accuracy will be high and it will go smoothly in the path. Decision making. At each junction, the robot checks which path are available using sensor inputs. Based on predefined rules, left hand or right hand, it chooses a direction. Detect dead ends. If the robot reaches a dead end, no line in front of line, it will backtrack. Then it will come back to the original position and it will follow the line. Okay, algorithm explanation they have shown. Construction steps. Chases will be there. You can get it outside also, or if you can if you want you can build it. Chases you can build it, and you can mount the sensor on that. motors and motor driver. Connect the sensors to the microcontroller and configure pins. Program the microcontroller with the maze solving algorithm. Test the robot on a simple line maze. First, you can check for the simple line maze. After that, you can put it in a complicated thing. Challenges in line mazing: intersection handling, accurately identifying T junction and cross junction, decision making logic, correctly choosing turns at the intersection, backtracking, efficiency handling dead ends and retracing the path, sensors noise and accuracy, fine tuning sensor sensitivity to ensure accurate line direction. So sometimes the light also will be a challenge. That day also we felt, I mean, we experienced that. So there is overlight in the sense the motor, sorry, the sensor will be difficult to take the decision. So lighting also we have to check once. Advanced features, it's like optional, so we are just suggesting if you want you can use this. So there is a method called PID. Have you heard of PID? PID control. Hello guys.
No, sir, we
Clear?
never heard of that. No, we don't know.
Yeah. Okay, so there is a thing called PID control. So it's called as proportional integral derivative. It's like a formula. The values will be getting from the sensors. So proportional integral derivative. So the value you are getting, you can just calibrate it and you can just use this formula thing. So you'll be getting some feedback. Yeah. So which will be in a control system actually. If you have the control system paper in your department, you'll be learning this. So this is a method of getting that smoother thing. Yeah, here it is. Set point summation. So first proportional integral, then derivative you have to do. This process will be following, and the feedback will be coming to the same thing. So here you will be getting the accuracy. So next one, mapping the maze. Use advanced algorithm. Okay, there is an algorithm called A star or Dijkstra to create an efficient path once the maze is learned. And sensor array, using more sensor can help better detect and process junction and sharp turns. So this is optional. You can anything. Sensor array is nothing. The same. He Niranjan showed na. So he has used five array of sensor. Okay, five sensor he has used. Okay, almost we came to the end of this session. If you have any question, you can ask. Next we can, if you are interested, we can you can register in this Techfest. I'll share you the website. I'll share you in the chat. Yeah, before going to the Q&A, you just if you're interested means you can go into this techfest.org. So you'll be getting screen like this, and you can register in the thing. First you have to sign, then you have to register. You can sign in, use your Google Gmail ID. You can. Okay, fine. You can register later also, but you just discuss among your teammates also. You can just register, not a problem. So now it's time for question. Yeah. Yes, Surya. So,
Already discussed that sometimes due to broad daylight, it would be hard for our IR sensor to detect all that. Can we
hmm.
connect, like use one IR sensor and then another like ultrasonic sensor, and we can merge those two signals, and can we get that?
Okay, ultrasonic sensor.
Actually,
How
the
will
thing
you?
is like uh,
Yeah.
we are using IR sensor and ultrasonic sensor. Ultrasonic sensor we are keeping there, and like it will also detect the distance from any obstacle like that now. So we'll keep
Yeah.
like the minimum distance should be this value, like
Uh,
2 centimeters. Then we'll take turn like that.
okay. The problem is ultrasonic sensor will detect from 2 centimeter. Shortest distance it will detect. I understand, but it will not detect the lines, right? I mean the object like lines. What you're telling.
That's
For example, see both the values, both the black as well as white, it will detect only. Okay, it will consider it as an object.
yes, sir. That's
You
why
understand
I'm
now?
telling that. Yeah, I got that. We are using IR sensor as well as ultrasonic sensor. But like this ultrasonic sensor gives us a backup. Like in broad light conditions, the ultrasonic sensor signals will be merged with the existing IR sensor. That's what I'm telling.
Um, no. See, the thing is, ultrasonic will detect objects. IR sensor also will detect object in a shortest range. Okay, but this black and white, that reflection of light is there, no? So that will not be
Yeah.
done in ultrasonic sensor. Okay, ultrasonic
Okay.
is like sound waves. Okay, that is different. That is like echo. So it uses the principle called echo. So based on that, it is getting. This is like different reflection of light. So if ultrasonics are also like
Basically,
a
I'm
principle is like
asking
reflection
that
of light. Huh?
can we use two different sensors, and can we merge those signals and get a one final output? That's what I'm asking.
That's fine. I'm understanding. But see, if
If
you're using
possible,
ultrasonic, you will not
if,
get the proper.
if possible, how to do that? I'm asking that, sir.
Yes. No. We haven't tried it, but logically, if you are seeing now, so that will be. I don't know, like how it will work. That's what
Okay,
I'm
okay.
saying. Telling like here, reflection of light is the main thing we are using. Ultrasonic is something different, so which will detect using sound waves. If you want, you can try once,
Yeah.
but most probably that will not work actually. You will not get the perfect output what you're expecting.
Can we get
Sure.
PID
I'll
for
share.
two different sensors? Like,
Sorry, PID.
can we detect PID those two sensors means collectively, and if we
You can
taking
use
two
it.
or three IR sensors.
You can use it. You can use it.
Thank you, thank you.
Yeah, sure. I'll share you that PPTs in WhatsApp that you have shared in the meeting. Okay. Okay. So any other questions? Thanks, Prashant. Thanks for the question. It's a good question.
Sir, on the website registration page, there is a column called CA reference. Shall we keep anything in that?
What is it? CA reference.
Yeah, yeah.
1 minute. Let me check.
CA reference.
Which one you are trying? Cozmoleclnch.
Yeah, we'll give you that. The campus ambassador reference will be given.
Yeah. Thank
Okay.
you, Surya. Okay. So guys, you are registering on that. Yeah.
Sir, there are some network issues. Can we register after 1 hour like that?
No problem. But you can register. No problem.
Okay, sir.
Yeah. I will share you the things in group also. Like, so Surya, I'll share you the documents. Okay, it's already available in the Techfest thing. Okay, I'll share you that PDF. You can go through the rules and regulations and you can do. Yeah, CA is posted in the chat actually. You can just check once. Surya has posted.
Hi Prashant, please check chat once for CA reference ID.
Hello, I didn't get you. What someone asked me?
No, CA, right? CA. Yeah. So Surya has shared the CA, which we have asked, right?
I got that. I pasted it.
Yeah.
Okay, guys, that's it. Over.
Yeah. So how many of you registered? Can you just confirm?
Like we
Srinivas
can
will
raise
do post this session.
those who have registered.
Okay, Prashant has done. If you have any doubt on the registration, please tell.
There is a discount page on that, like two um, two members collectively registered means 200 off, and like three members it's 400 off, four members 500 off. Then like our classmates will collectively do that, then we'll get discount also.
Okay.
Yeah. The event takes place on December 18th and 19th. Okay.
Yeah, just given in the
Hyderabad
17th to 19th.
28th October.
No, like
Yeah, zonals.
artificial.
Sorry.
To that website and went intelligence workshop, and it's telling like the date 19th, 18th and 19th of December, isn't it?
So the Techfest happening in 17th to 19th. Zonals will be like a very short period, I think so. 1 minute. Computation. Some network issue from my side.
Yeah.
Hello.
Hello.
Sir, what if we got any doubts in the registration or the process of the making is all these bots? What if, how could we contact you or someone?
Okay, when you're doing
You can contact
a
in the
project,
group.
if you
What's it? Sorry, I didn't get you.
WhatsApp group for the workshop, right? You can contact in the group.
so you'll be having a WhatsApp group, right?
Yes, sir. In that only admins can send they said that only admins can send the message.
Okay. Today we'll change the setting.
Personally, personally, we can DM. Okay, sir. Okay, fine. Thank you. And all the parts like Arduino or something, all the parts we can get in online or
You can get it in the shops also, like online also you can get, or locally in the market also you can get it.
okay, sir. Okay, sir.
Yeah. Surya, you have any group like among all the people, like? Hello.
Yes, sir. We have created a group, WhatsApp group for this workshop.
Okay.
So we can chat
Okay.
in that group.
Okay. So you'll be guiding, right? Who are having doubt in the
Yes, sir.
registration?
Yes, sir. Sure. I
Okay,
will.
okay. Yeah. Please post the doubts in WhatsApp group, so Surya will guide you in that. Kindly register it.
So, hi guys, you can also DM me if you have any doubts, or you can chat in the group.
Okay, guys. So, any other questions from the presentation? Okay, I forgot to show one thing. 1 minute. Let me show the Arduino thing. So I said the Arduino IDE platform, right? So let me show that. Then we will wind up this session. So this is Arduino IDE. So this is like available in internet. You can just it's like free access only. You can just download it. Okay. So once you download it, so you'll be yeah. So once you're downloaded, you'll be having a screen like this. Can you able to see Arduino screen?
Yes, sir.
Yeah. So you'll be getting a screen like this. So here you can select the board. Because Arduino not only Arduino so we'll be having some versions in Arduino. So Arduino Mega is there. This is Arduino Mega. It's the next version of Arduino. The only difference is the IC will be changed here. The IC is different IC here, and you'll be having lot of pins, lot of digital pins and lot of analog pins. So that is the difference. And IC also like Atmega 2560 as they mentioned. Atmega 2560 comparatively to Arduino, this is like little fast, and a lot of digital pins you have. If you are running out of pins in Arduino, you can go for Mega. And there is one more thing called Nano. So this is Nano. The name itself it is there. No, Nano means small, so small size. So it's like our thumb only. Thumb finger is there, no? That much size only it will be there. So this is also same like you can. So you'll be having some pins here. You can control it, but limited number of pins. But for the portable projects and all, they might prefer this only. Yeah. So coming to Arduino IDE, so this is Arduino IDE. Here you have a file and edit,
Can
sketch,
we
other
download that?
things like yeah, you can download it in internet. Just go to Arduino IDE.
Okay.
Just type Arduino IDE down. So there will be an Arduino official website is there. You can go here, and the latest version will be there here. You can just choose your system like a system OS, whether it is Linux or Windows or Mac OS. Check and then just hit this. Just download. Click on just download. It will be downloaded. It's a free access. No need to pay and all. Just download you can give. So you'll be getting this platform. So here you can select the board. So there are two default function they have given. One is void setup, another one is void loop. So in void setup, you will be getting you'll be putting the code. It will run only once, and you can set the pin mode, everything here, whether it's an input or output. You can set here. Void loop, in the sense, what is loop actually? Generally, what is loop?
Thing that executes again and again, cycles.
Yeah. Yes. So loop will be repeating the function again and again. Okay. So all the things, like if you want a continuous thing, means you can put it inside the loop. That's it. Niranjan sir.
Yes, sir.
Sir, do you have Arduino and Arduino USB cable?
Yeah, we are having.
Okay, sir. Sir, can you show the blink LED? Inbuilt LED only you can show, sir. That code only. I mean, you can just directly upload the code. The uploading part and all I'll show here. You can just show the working. Meanwhile, I'll do the coding here.
Yeah, okay, done.
Yeah, sure. So as I said here, white setup. So here you can set up the pin mode. So in Arduino, no, so the 13th pin is a inbuilt. There will be an inbuilt LED in that. Okay. So here I'm going to set the pin mode. So the LED built-in is the 13th pin. So if I'm uploading this code, the code will are without any LED only this will work, because an inbuilt LED is there in that. Void loop you can just give. Okay, digitally I'm going to give some signal to the LED. So it's a LED blink now. So I'm just giving a delay. Delay in the sense, what is delay? Generally, what is delay?
Waiting for a certain period of time.
Exactly. So it will wait for some time. So here I can give some 2 seconds. So here I'm giving in 1000, because you have to give in millisecond. You should not give in seconds. You have to give in milliseconds. So that's it. Now if I'm uploading the code, if I don't have a Arduino in my hand, so Niranjan sir will be uploading the code. He also having the coding. Just showing the code, how to code it. So this is a basic code, and this Arduino ID is a case sensitive. Okay, uppercase, lowercase, it will check. If you are programming now, you have to look for the capital and small letter also. If you're giving wrongly, it won't work. Okay, board is missing. That is a problem. The other things are fine. Yeah. So now what I have done is I just written a code for LED blink. First I'm setting the LED built-in, that output. So now I don't need to connect any I mean LED in the outside. So there is a built-in LED which will be in the Arduino. So that will glow, that will blink actually. So the LED is an output, as we mentioned. No? The LED is an actuator. It is an output. So in void loop, what I have done, so I have given the code as digital write. So digital write means, digital means like digital signal high and low we will give now. So the LED built in comma which pin, okay, LED built in comma high we have given. So it will be on for 2 seconds. Next it will be off for 2 seconds. That's it. So this will be repeating because which I have put it in, which I have put in the loop. So this will be repeating. That's it. So this is the basic code. So once after doing the code, you just connect on Arduino Uno using a USB. That will be a connector actually. When you are buying Arduino, you just buy a connector also. Arduino USB cable, they used to say. So like this one USB cable will be there. So you have to connect it to the Arduino. Then you can code. You can just check for the port number. Device manager. In your computer, you just check device manager. It's normally in all the computers. So here I haven't connected any Arduino board, so it's not showing. In if you're connecting, it will directly show some USB serial, or sometimes it will show Arduino also. Okay, based on the board how they have programmed. After this, you just compile this once. This is called verify. This is uploading, and here you can select this COM port. You have to select from the device manager. See here it is COM3 is something else like Intel. If you're connecting Arduino, it will show another one COM port. Here that COM port you have to select it from here, and board also you have to select. So once you're selecting, you just verify this. So it will get compiled. So there is no error in this code. So it will show like this. And once after doing this, you just upload this, then the board will work surely. And so there are two things. One is serial monitor, one is serial plotter. Serial monitor is for getting the output. For example, if you're connecting a sensor, in the sense those outputs and all can be printed in the serial monitor. If you want to see the graphical thing, I mean the graph based thing, you can use serial plotter. So based on the signal, it will get vary these things. So that's it about Arduino IDE. So some, in addition to that, some libraries are there, and those things and all you have to I mean you have to download when you are doing for some sensors and all. And boards also, board manager, you can just download the board manager. So whenever you are using multiple boards like ESP32, Arduino, some other Arduino you are using, if that library is not there, sometimes the program will not work properly. So you can just download that using the board manager and also the library also.
Gokul sir,
Yeah.
sorry for interrupting. This is me.
Yeah.
Can
Yes.
I blink LED?
Yes. 1 minute. I'll just stop sharing. Guys, you have any doubt in Arduino IDE which I showed? So you can try it once. Okay, it will be available. It's a free source now. You can try it.
Okay.
Stop sharing. I'll just stop the sharing.
Sure, sir.
Yes, sir. Naranjan sir, over to you.
Yes.
Yeah. So now you can see that red light is blinking and going. Can you see? Sir,
Yes,
how
sir.
many seconds you have given, sir? 2 seconds, sir. Naranjan sir?
Yeah, 2 seconds, sir.
Okay, sir. So this is what. So external LED also you can connect. You can connect it to the pins, digital pins. Any pins you can connect. Positive can be connected to digital pin LED. Negative can be connected to the ground of this one, Arduino. Yeah. Yes, sir. So can you go to device manager once?
Sure.
Yeah. So I said no. So sometimes it will show USB serial. Sometimes it will show Arduino also. It based on the board only it will show. Depends on the board. The manufacturer, they have set this. Yeah, so that's it about Arduino IDE. Thank you, sir.
Thank you. Thank you.
Yeah, so if you have any question, you can ask, or else we can just wind up the session. I need some feedbacks from you. I'll show you the QR code. You can just scan it. You'll be getting a form. You can just fill it. If you have any question, you can ask, or else you can start filling this feedback. If you're done, just kindly acknowledge in the chat. Yeah, I'm sharing now. The PDFs I'm sharing now. Guys, kindly please acknowledge in the chat once you're done with the feedback. Thanks, Harshini. Thanks for the feedback. Yeah, thank you, Jagdish. Yeah, thank you.
Sir, can you reshare the QR? It's not verified.
Oh, not.
Thank you.
Yeah. Thank you, Harsha. Thank you, Aparna. Thank you, Suryavati. Thank you, Srinivas. Thank you, Kedari. Thanks, Surya. Thank you, Mohan. Yeah, if you have any question, you can just raise your hand. Yeah, because we are going to wind up the session. That's why. Yeah, Surya. Fine. We can just wind up.
Yeah, okay, sir. I deem it as a privilege to propose the vote of thanks on behalf of all the students of JNTUK University. First of all, I would like to thank Niranjan and Gokul sir for the wonderful session on robotics, and I thank our college principal, vice principal, and our HOD ma'am for their cooperation in the arrangement of the session. And I also thank all the participants who have participated in this wonderful session. At last, I also thank one and all who have directly or indirectly cooperated in making this session very successful. Thank you all.
Okay. Thank you, guys. Thanks for the patience. Thank you, Surya. Thank you, Vamsi. You guys organized it very well. Thank you. Thanks for that. Thanks for the HOD's principals. Yeah. Thank you, Niranjan.
Yeah, thank you, sir. Thank you, everyone.
Okay, sir. Thank you, sir. Thank you, Vamsi.
Yeah. So can wind up the session.
Okay, sir. You can share me some files, okay, so that I can share with other people.
I'll just post it in the group, WhatsApp group. Okay.
Okay, sir.
You can read it. Yeah. Thank you. Thank you,
Thank you,
Surya.
sir.
Bye. See you
Okay,
then.
sir.
Thank you, guys.
About the
Thank you, everyone.
okay.
Thank you.
So clarity about the dates and all. The Techfest is going to be conducted from 17th to 19th of December in IIT Bombay. The workshops and all are now on early bird discounts. Tomorrow is the last date for the discounts. So, and about the competitions, there are 4 competitions held: the Cozmoleclnch, Meshmerize, Code Decode, and the Olympiad quiz. So, all these 4 are the competitions. And before going to IIT Bombay, they have journal competitions, and we belong to the Hyderabad journal. And these Hyderabad journal sessions are conducted on 20th October in Hyderabad. So after being selected in the Hyderabad journals, we will proceed to the IIT Bombay. And workshop and all, you can see the details in the techfest.org website. The details will also be shared in the WhatsApp group also. Thank you all. Thank you.
Cool. Thank you. Thank you, Shamsi. Thank you.
A project on the 20th of October in Hyderabad, sir.
Yeah, journals are happening now. So there you have to present it. So once it is got selected now, you will be going to the Mumbai competition.
And any fees to be paid for the participation.
Sorry.
Fee to be paid for the participation. I mean, any
Fee
registration.
details. Let me check. Give me some 10 minutes time. Okay, these details and all I'll give it to Surya.
Okay,
Okay.
sir.
So
Okay, sir.
he will be communicating in the WhatsApp group.
Okay, sir.
Okay, sir. Thank you. And Srinivas, I will share all the details in the group, WhatsApp group.
Yeah. Thank you. Thank you, everyone. Bye.
Thank you, sir. Bye, sir. Have a good day, sir.
Yeah, you can just stop the recording. Okay. So this will be with you, right? Hello.
Yes, sir. Okay, sir.
Yeah, you just share me the recording also. Okay,
Okay.
later. Yeah, thank you. Bye.